purpose, we are just going to discuss here the brief discussion about the mathematical modeling and simulation. Just see here that if we have to design any system, then first of all we have to define it, means what is the system, and after the definition of the system, that is that we already used to define in any field of the engineering, that may be field of the electrical, mechanical, civil, or whatever is the field of the engineering, even if whatever the field of the management, we generally define it that it is a collection of the parts that works together to achieve a goal or the task. And set of the object, it is also defined as the set of objects and the relationship among the objects viewed as a whole and designed to achieve a purpose. And we generally categorize the system in two categories. One is without the feedback, and the second one is with the feedback. That is, in order to get the accurate result, in order to get the desired output, there is a need of the feedback. Whatever is the system, that is the technical management, or whatever is the type of the system, there is a need of the feedback, and accordingly there is a requirement of the modification and the improvement. And after the definition of the system here, there is a need of the effectiveness. What is the engineering? Engineering is, as we define, engineering is a branch of study in which we utilize the rules, regulations given by our seniors, scientists, mathematicians, even philosophers and society persons, either to design a new system or to maintain the existing system. And when we say maintain the existing system, means there is a need of the effectiveness, and so effective methodology has to be incorporated in the existing system. And what is the effectiveness? When we define the effectiveness, it is nothing but that it is a function of the human skills, software and the hardware, also having the some circumstances also related to the situations here. And after defining the system and developing the efficient algorithm related to the system, before the designing, there is a need of the conversion of the requirement in the practical form, because the requirements are always ideal here. So some algorithms or the approaches will be utilized in order to convert the requirements to the specifications. And when we say specifications are nothing but they are the process to determine the parameters related to the algorithm that is required for a particular purpose, or in order to get the purposeful output here. And after the specification, next step is the decision of the system, means whether we are interested for the static system or the dynamic system. When we say dynamic system, means there is a need of the memory, and when we say the dynamic is what? The capability to contribute something in order to get the better result. In order to contribute, there is a need of the memory, and in a static system there is no memory. So when we develop the mathematical model either to the static system or the dynamic system, in the static case there will be the polynomials, and in the dynamic system, if the system is dynamic and it is the analog, then that will be modeled with the differential equation, and if it is dynamic and the digital, then it will be modeled with the help of the difference equation. And generally we prefer the digital processing here for the purpose of the accuracy, efficiency and other advantages here, because in that here the digital system we utilize the difference equations. So if we see here, the input is described by the xn and output is described by the yn, then in general we can describe a mathematical model, that is summation of the a case xn minus k, and the limit starting from minus infinity to plus infinity is equal to the summation of the b case yn minus k, and again limit starts from minus infinity to plus infinity. But minus infinity to minus 1, it is not a feasible solution. It is an anti-causal here the system, or anti-causal approach. That's why we discard it. And again from 0 to infinity, it has a very long range of the operations. So in order to get here the finite number of the operations, we generally use the finite number of the upper limit, that is in order to incorporate the finite number of the operations, that is the here the a case xn minus k, that will be have a limit from k equal to 0 to m, and B case yn minus k, k0 to n, and for the m and n both are the finite numbers, and again if we transfer all the yn minus k terms towards the right side, except only the vk yn minus k, where k is equal to 0, and we assume that v naught is a coefficient and it is equal to 1, then the equation becomes something like in this manner, that is the yn is equal to summation of the minus k is equal to 1 to n vk yn minus k, and the plus another term is summation ak x n minus k here. This is the difference equation for one-dimensional equation, and similarly we can develop here the equation for the two-dimensional system. And if we are interested for the continuous system or the analog system, then we have to use the differential equation, and we can develop this mathematical model for the differential equation. Whatever is our field of engineering, whether we are from the electrical engineering, mechanical engineering, civil engineering, chemical engineering, or the technology field, means here the oil technology, paint technology, plastic, whatever is our field. But first of all, we have to develop the mathematical model as per our requirement. And if we have developed the mathematical model, then naturally there is a need of the analysis whether this model or this mathematical equation will perform as per our requirement or not. So here if we see this equation, then we will find this equation has the very important parameters. Those are known as the coefficients. When we say we have to design any system, so meaning of the designing is nothing, but we have to decide and we have to compute the values of the parameters, here the coefficients, and this concept is known as the designing of a system. So first of all, we have to develop the mathematical equation, and then we have to find the values of the coefficient here. Now see, if we see the coefficient here, coefficient means parameters of the system. Again, we are saying this is a general system, not a specific system related to the electronics or electrical engineering. It is a general system here. Now, if we consider here the coefficient, now these coefficients may change their values with respect to time, or they may be considered constant with respect to time. For example, if we consider a system, and system has so many parameters or so many components, and their values are fixed, it means they are not affected with time, then that type of the system is known as the LTI system, or the linear time invariant system, and this is also known as the deterministic equation or the deterministic approach. And in this one, when all the A case and B case are constant, that is written by a set of the equation having the coefficient constant here. But in another case, what is happening here, the A case and B case are changing their values with respect to time, means the components are changing their values with respect to time. If any system has so many components and the components are changing their values with respect to time, it means as per the requirement, means if there is any requirement in order to get the new component, then the value of that component will be changed according to our need or our requirement. And such type of the system is known as the adaptive system, and these are represented with the help of the random equations, random values here of the equations, and it is known as the stochastic equation. So here if we have developed any mathematical model, whether in the continuous domain or the discrete domain, then that system may be either the LTI system, linear time invariant system, or the adaptive system, or the stochastic system, depending upon the values of the or the nature of the A case and B case. Now, after the development of the mathematical model, next concept is to get the response of the system. Means what type of the response we are getting here. We have to here anticipate what will be the response of this type of the developed model here. So when we say response means now we are moving to another domain, from time domain to the frequency domain, and in that domain we have to see what will be the here the pass bandwidth frequency, what will be the stop bandwidth frequency, what will be the bandwidth or the range of frequency in which the system is said to be the suitable, and what is the range of the frequency in which we can say the system is not suitable for our purposes. So on the basis of the frequency analysis, now the system may be categorized into different categories like the low pass, high pass, band stop, or the band reject. So after the development, next is the response type. and this is on the basis of the response we define the system, either the moving average or the autoregressive. Now again coming to this point here, as we have described that the system may be without feedback or with the feedback. If the suppose we consider any system and system has the feedback, and now if the system is here excited by any input, and say the input is impulse, generally we use the impulse or pulse in order to test the signal. See here, why we prefer the pulse in order to test the signal. If we see the pulse here, pulse have a nature of the abrupt changes, that is from 0 to 1, and at the same time there will be DC level, and again from 1 to 0. So it means there are the different levels starting from very here the random changes from 0 to 1, and then DC value no changes, again 1 to 0. That is worst and best condition, both are taking place in this one. That's why we use this type of the pulse in order to test the here the any model or the system. And when we say impulse means width is pulse width is very very small, and ideally is considered 0, having the infinite height here. Now if any system is subject here the impulse is subjected to any system, means system is disturbed or excited by the impulse, then we will get some response here. And now if this response is again considered as input, means autoregression is taking place here, then what will happen? There will be infinite duration that is required in order to get the settled output, and this type of the system will be known as the infinite impulse response system. Or since there is autoregression, so this is also known as the AR model. And in another case, if there is no feedback, so if there is no feedback here, again if we see mathematical model, then if there is no feedback, only the second term will exist, only this term will exist here. And if there is feedback, means whatever is the output after the some delay, it will be considered as the input here. So here and minus sign, that is 180-degree phase difference here. Now see here, if we consider this type of the system, then there will be the autoregression, and it is known as the IIR section here, infinite impulse response system. And if there is no feedback, only second term exists here. So if we see the second term here, AK is multiplied by X and minus K, and then their summation, it looks like averaging values here. But in this one, what is happening? The coefficient is changing. So this is known as the moving average type of this model, or the moving average model here. And if it is disturbed or excited by any pulse, then after certain duration, we will get here the settled output or the final output. And that's why it is known as the finite impulse response system here. So again, whatever is the system, that is the LTI, deterministic, or the adaptive system, that may be categorized into two types of the system, that is without feedback, EMA moving average, or the FIR, with feedback, IIR, or the autoregressive. And also if we transfer this one into the frequency domain, then in this case, there will be the here all the zeros, and in this case, there will be the poles and zeros also here. Now, if we after this design here the design method, so far we have described that first step is the definition, and the second one is the determination of the parameters, third is the decision, fourth is the derivation of the equations, and the fifth one is the design methods here. So we have described here the two design methods, that is moving average and the autoregressive model here. And as we have discussed that during the time of the design and analysis of the system, there is a need of analysis in time domain as well as frequency domain. So in order to analyze any system in time domain as well as the frequency domain, the different types of the transformations are used here. For the differential equation, we generally use the Laplace transformation, and for the differential equation, we use the jet transformation. And in Laplace transformation, if we apply here the Laplace transformation, then here the mathematical model or the transfer function will become a function of the S, where the S is the complex frequency. Similarly, when we apply here the jet transformation, then it becomes a function of the jet. And if we replace the S by here the j omega, or sometimes we replace it sigma plus j omega, and Z is replaced by the R plus j omega, e to power R plus j omega, or only e to power j omega, then whatever is the model, that will become a function of the omega, having the two parts, real and the imaginary. And that is that have the two type of the responses. One, amplitude is changing with respect to frequency, and the second phase is changing with respect to frequency here. If we analyze here the variation of the amplitude with respect to frequency, that is known as the amplitude response. And if we are here analyzing variation of the phase with respect to frequency, that is known as the phase response, and in total we call it the frequency response of the system. But and when we replace the S by j omega or z e to power j omega, then whatever is the transform, that is known as the Fourier transformation or the FT. And when we apply the Fourier transformation to the discrete time signal, it becomes the DTFT. And again, if the sampling or the discretization takes place to the DTFT, then it is named as the DFT, discrete Fourier transformation. And again, if we exploit the properties of the here the symmetricity and the here the this one homogeneity, symmetricity and additivity, as well as the periodicity, then we find a new concept, that is efficient DFT, or the here the processing of the DFT becomes efficient, and it is named as the fast Fourier transformation or the FFT. But whatever is the type of the transformation, in these transformation, we will find that these type of the transformations are suitable only for the non-stationary signal. Like the speech is a stationary signal, but this type of the transformations are not suitable. So for the purpose of the here the non-stationary signal, we utilize the STFT. Previously we used to utilize the STFT, that is the short-term Fourier transformation, and then after the some enhancement in this one, we utilize here the wavelet transformation. In continuous domain, it is named as the continuous wavelet transformation, and in discrete domain, it is known as the discrete wavelet transformation here. Now, again, we are coming to the point that here after the analysis, next is we have to select the design criteria. After the analysis, we have to see what is the performance of the system. When we say the performance of the system, means what is the speed of that algorithm, or what will be the speed of the processing, or what is the delay that will be incorporated in that one, or what will be the area on the silicon wafer, or what is the memory space that is required in order to process that particular algorithm, or what is the power consumption. And these are the three main parameters which are required for any type of the algorithm. And the fourth parameter is the finite word length effect, that is required in the case of the digital processing. If we are interested in order to process any information in digital domain, then analog has to be converted into the digital. But in here the in order to process it completely, there infinite number of the bits are required as word length, but it is not possible. So the finite word length is here the selected, means approximation takes place, quantization takes place here. That's why there is a effect due to the finite word length, and it is known as the finite word length effect. So during the time of the analysis of the performance of any system, we have to consider the four parameters, that is what is the power consumption, what is the memory space or the area required on the silicon wafer, or what is the speed of the processing or the delay related to that particular the algorithm, or what is the finite word length effect. If we see, then these four parameters are related to the four here the properties of the diamond, and the value of the diamond is decided on the basis of the cut, color, clarity, and the carat. Similarly, the performance of any system is decided on the basis of these four parameters. That is, value of that system will be decided on these four parameters here. And after the analysis, we have to select the approximation, either the available design criteria approximation method, or we can develop our own approximation or the design criteria here. For example, if we are interested for the moving average, then there are so many methods, and we can utilize any one method among these methods. And we will here elaborate this section during the time of the signal processing toolbox in order to design the filters here. And in order to design the autoregressive system, that is the analog to digital, we can first of all we have to design the system in analog domain, and then that design system or that design filter will be transformed into the digital domain here. And after the here the designing here the approximation, again we have to write the code and we have to develop the system. And for the purpose of the here the architectural description, Now there is a need of either a particular language or here the graphical representation. And there are the three categories of the languages, that are the prescriptive languages, descriptive languages, and the applicative languages. Prescriptive languages are the like the C, C++, etc. here, and descriptive that describes the hardware architecture like the VHDL or the Verilog are the here the descriptive languages. Applicative languages like the MATLAB, etc. here. And in order to graphical representation, we can use here the block diagram in order to describe the architecture of the algorithm. Signal flow graph that describes the information about the signal flow. Data flow graph describes the one iteration. See here, for a particular value of the k, it will be known as the one iteration. For example, if we use here the k as 1, then for the k is equal to 1, it is iteration. From k is equal to 1 to the maximum value of the m and n, this will be known as the algorithm here. So in order to describe the algorithm, total algorithm, we will utilize here the dependence graph, and for one iteration, we can utilize here the data flow graph here. Now, what we have to do, first of what we have to discuss in this one, first of all, we have to understand the application problem. Then we have to design. The next step is this algorithm has to be converted into the implementable form of the algorithm. Then efficiency has to be incorporated, and after this one, there is a need of the implementation either in hardware or in the software. So whatever is the code that has to be downloaded on a given target. And for example, if we are interested in order to download our algorithm or the target or the concept on a given hardware, say the processor, that is the TMS320C6713, that is the Texas Instruments here the processor. And then for that purpose, we use the ID or integrated development environment that is known as the Code Composer Studio. And Code Composer Studio had the different sections like the compiler, assembler, linker, loader, etc. And then it is downloaded to the given target, or we can utilize here the .out file for the purpose of the simulation or the emulation here. So this is a brief introduction about the design and implementation of the system.